It should actually be week 7. I forgot to change that. This is week 7, so almost 2/3 of the way through. And this week and the next 2 weeks, we're going to be looking at querying the data and not looking at generating data or tables and all that. So looking at the past weekend's quiz, 13 people wrote, so that's 2 more people in the previous week. The average is down though. But at least we've had 3 people that got 100% again. It's like, I don't know, it's the only thing that's constant about. 3 people every week of 100%. It's not the same 3 people though. Okay, so look at the bottom 3 questions. So there's a clear bottom 3 this week. So question 10, at the worst. So it's looking at the relationship. So we want to model a customer and credit card entities as map, credit card, and double, where you store the current balance along with the credit card, which 2 of the following steps are correct about this relationship. So first off, looking at the relationship in the map there, because the value isn't an entity, we know it's not a one-to-many or many-to-one relationship, so it's going to be an element collection, so that really tells you a bit about what the answers can be. So we can already cut off that second last one-to-many relationship. That's not going to be one-to-many because it's not an entity as the value. And you can model the credit cards as an element collection, so that's definitely true. Then the other 2 that's left is the one between the map key column and the column. They hold the value, so because this is an element collection, you use the column to specify the value. So those are the 2 correct answers. So I think it's just, like I mentioned last week, just looking at when there is a map, the value has to be an entity. If it's an entity, it's going to be a one-to-many or many-to-one, otherwise it's an element collection. And as soon as you see that, with the other questions, you really can sort of start forming, well, these are only the possible things that could be there. And then the question 3, 46%. Also not too great. This is once again looking at your customer and your credit card. So we want to model a map here. And here we've got the credit card actually being the value, so it's an entity. So once again, it tells you it can be a one-to-many, many-to-one. So looking at the different answers here, you can see all of these are maps. But the bottom 2 are maps, which are, and they are organic maps. So they're not actually saying, they're not generics. So not saying what type it is. Now, whenever we're using non-generic types, you have to specify the element type, the class that it's going to be. And neither of these 2 do it, so both of those are already out. So the fact that this one's got map key, enumerated map key doesn't matter. The fact that they're not specifying the element types really cuts them out. With this one, we've got our one-to-many for map key, which is card type. And the card type we get from a credit card is that's sort of one of those special type ones where the key is one of the fields in your value, which is an entity type. So the JPEG does not require this kind of mapping. Well, it does. So the correct answer is the top one, because these bottom 2nd and 3rd one fall out because they don't specify the element type in there. So in the exams on doing these things, always go and look and see, honestly look for the answers which are the correct ones. Look for ones which can't be right. And you just kind of cross them out and think with on the exam you can actually right-click on those answers, and in the exam it actually crosses them out. So it also makes it a bit easier. So if you have to guess the answer, it at least takes some of the, ups your percentage for getting it right. And then the last one is question 6, 53%. This one is once again, we've got our customer and credit card, and we want to map this entity. So credit card, which is the entity, has the key, and the double, which is an entity, has a value. So really, when we look in the element collection here, so this really cuts out the 2nd and the 3rd option. Only right option could be the 1st one or the last one. And this is an invalid mapping because the entity cannot be stored as a key in a map, and that's bullshit. Can be. So a key can be an entity, an embedded class, or a basic type. So the only one it could be is the top one. And that's the correct answer. So I think just go back and just look through this. It's important that to figure out that when the important one is looking at the value type, the key type, the only thing the key type tells you is the other type of annotations that can be on there. So if the key type is a basic and you've got your map key and map key enumerated and temporal, if it's an embedded type, you can only do the attribute overrides. And when you've got a entity as the key, you've got that join table stuff that you can bring in there. So it's your map, it's the join key type, key column or something, can't remember the name now. So those are the type of things. So you just, like I said, sort of the second or third last slide, excuse me, from last week, I sort of got all that rules. That's pretty much what you need to know to answer these questions. So, all right. So this week we're starting with querying. This first week is sort of introduction to querying, so we're going to look at the 3 different types of querying, or actually 4 different types of querying you can do. So looking at finding entities by their primary keys, which we've done before, looking at the JPQL, the normal native SQL queries, and the criteria API queries, and seeing how those work. So finding entities by their primary keys, we've seen this before, so I'm just sort of repeating the slide we've seen before. So you've got 2 functions on your entity manager which you can use. You can use your find, which locates an entity by its primary key. So looking at an example there, you'll say from entity manager find, we want to find an employee with this primary key, and it'll bring back the entity that's there. So one thing to remember, it doesn't bring back a managed instance if it is found. So that's the one caveat there. And the other one is pretty much similar to find is the get reference. And this is if you actually just care to find, to get the primary key value as part of your entity that you're returning there. And that'll be like when you want to add it as a foreign key or use it in another query where you just actually need the primary key to have a value. Important thing there, it only returns a proxy to the entity, so it's not the actual entity. And that also, if unlike the find, which will return a null, the get reference will actually throw a entity not found exception if it's not found. So that's just one thing to keep in mind there. So I've mentioned, I don't think there'll be actually any questions about this as part of this topic, but just so we cover it. All right, so looking at the normal general queries, like I said, so that find and get reference is the one way of querying, you can say, your entities and getting answers for it. The other one is, the three other ones are the JPQL, so Java Persistence Query Language, the Criteria API, and your normal native SQL queries. So all these queries can have joins, they can have aggregate functions, you can filter them, you can assign parameters to them, so they're like pretty much any normal SQL query you can do. All of these you kind of started from Entity Manager. I say so the Entity Manager sort of gives you access to your persistent context, and your persistent context keeps all the entities in there. So once again, Entity Manager using that. Then you've got sort of 3 main ways, if I can put it like that, to sort of start out of this. So for the JPQL, you've got your create query, which is your starting point for that. Your criteria API, you get your criteria builder, and from that you build up a criteria query and you use that to query. And then for your normal SQL, you do a create native query, which is the same as create query, except that it's going to expect SQL in there, normal SQL, instead of your JPQL in there. So each of these returns a interface, which you can then use to further add things, so set parameters, set hints, get your results, all that type of stuff. So all 3 sort of kind of use the same 3 steps. So first you go and create your methods. After you go and create your query, saying this is what I want to query, this is what the where clause is going to be, this is the joins I want to do. Then you go and set up anything else, like your parameters, all that stuff, and then you actually go and execute and say, get me my results. So all 3 of those sort of follow that same sort of little formula. There's more people on the call already. Nope. A lot of people are going to watch this on YouTube. All right, so looking at the JPQL queries. So before we start with a JPQL query, you have to do a create query from your entity manager, and then supply it with your JPQL query and the return type. You can either specify the return type or not. So if you specify a return type, which is the element that's going to, where the entity is going to be returned, you get a typed query interface back, which makes it more type safe than normal Java generics. If you don't specify the return type in your create query, it's going to return a query interface, which is not type safe, but you can cast it. So you'll have a normal casting issue. So if you're saying this query is supposed to return a employee and it returns a department and you're going to try and cast it, it'll probably work or not work. So JPQL looks pretty much like normal SQL. The big difference is instead of referring to the table names in your JPQL, you actually refer to your entities. And your entities are, one thing that's important is it's case sensitive. So unlike your normal SQL, which you can use uppercase, lowercase for table names, JPQL is actually case sensitive. So if your class name is uppercase employee, your entity needs to be uppercase employee. If you're referring to an attribute on that entity, like in your where clause or something, and that attribute has a lowercase name, it needs to be lowercase. So a normal JPQL query looks something like this. So instead of doing a select splat or select star, we're going to say select E, which is our little alias we gave to our employee class or entity. And that's just sort of the simplest way you can do it. You can also filter it with like where clauses and likes. So once again, selecting employee E. So E is our little reference to it. So we're going to select all our employees. Where E.name, and that name will be your attribute name, is equal to something like Sam. Or you can do a like. And the same as with normal SQL, you can use your little percentage sign as a wildcard, which means any amount of characters, or you can use underscores as well to refer to a single character. And they are going to ask this in the exam, so you need to know that. And the other thing that's a bit different from JPQL is that the joining works a bit different. Because we're working with entities, and we've actually defined our relationships on the entities. You don't have to do inner joins and outer joins and all that. You can just pretty much say, I want to select employee, and I want to join the relationship entities to it. So instead of saying I want to join phones, I'm going to join e.phones, which is our relationship we've set up on employees for phone numbers. So that's the only thing that works a bit different. Then you've got your normal aggregate functions as well. So we can do an average, a count, a min, a max, and a sum on there. And on your order by clause, you can have your having and group by bits as well. The only sort of thing is if you're going to do an order by, whichever field or attribute you're going to use in your order by field, you have to make it, it has to be in your select clause. So if you're going to order by employee name, you have to select employee name. And if you're doing an ordering, if there are any null values, this is sort of one of those things where the spec just says all null values should be together, either before all non-null values or after all non-null values. But it doesn't specify it should be before or after. So it's unspecified, so you need to depend on the provider. And the other thing, JPQL queries don't do inserts. So if you want to do an insert, you have to do a persist. So using intermanagers of persist. But you can do updates and deletes, which is kind of weird. I don't know why I can't do deletes if you can do updates and inserts. All right, so I'm going to do a demo with this, but this is kind of show you what it looks like. So you can see we've got our manager here, our entity manager. We're going to do a create query. And when we do a create query, and we specify the type there, like I said, stop jumping. So it's going to return an employee class as the entity type is going to return. Then I can use a type query, and I say, well, the type is an employee. So it's going to make it type safe, and I can return it, and everything's going to be checked for me. I have to select, so I want to select all this specific one, I want to select all the employees that belong to a department. So from a department, I'm going to join the employees attribute to it. Stop jumping around. Where the name is equal to a parameter. I'm going to select that. That's going to bring back my query. So from this query, we go on to the next section, which we can actually go and set parameters and all that. So I'm going to get to that now. So that's just sort of quick looking at what that code will look like. The other way you can also do queries is named queries. So this is one of those things you can do to actually help with performance, because the name query, because it's already set up front, it's a query that can be reused, and that the provider will set up once, and once it hits the database, hopefully the database will cache that specific call. So it doesn't have to compile it in quotes every time you call it. It also helps to sort of put a lot of things together, so you don't have that sort of SQL queriness inside your code. So you can move this into your actual ORM mapping files in the XML there. So the one way of doing it is using the, the @named query attribute on top of the class. So you generally try and put the name query above the class that's the main component of what you're going to be returning. So if you're going to be returning employees, put it above the employee class. If you're going to be returning departments, put it above the department class. But it doesn't really matter where you put it. It just needs to be somewhere. You can also do a name query element in XML. And if you've got, of course, there'll be instances where you might have more than one named query, and then you can use the @named queries attribute, and then just have your list of named queries in there. The important thing is that these named queries are scoped inside the persistence unit of the entity element they belong to. So if you've got two different persistence units, you can't go and call the named query in a persistence unit that your element isn't in. So even though you can put these named queries on any entity, they're only going to be in the scope of the entity's persistence unit that you've put them on. So for them, you're going to use your create named query method. So instead of using create query, you're going to use a create named query, and you're going to supply a name. Once again, you can define the type is going to be returned or not. That return the query or a typed query. Just looking what that look like. So if I go to my employee class here, you can see I've got a name query on top of it here. I've given it a name. It's called employee.listAll. So this is one of the conventions that you can also follow, is instead of just saying the name is list_all, because there might be a few list_all queries in the same persistence unit, you can say, well, the type of class I'm going to be returning employee.listAll. So you can maybe call it Hungarian unit notation. I call it convention. And then you can have your query there. So because this is JPQL, it's a normal, just select all our employees. So using employee, aliasing it with NIA, and we're going to select all of those OKs back. Then when we actually want to use it, going back here, like say we use our manager again, our entity manager, do a create named query instead of create query, like we did there, and just give it the name you're going to be using and the type you're going to be returning. So if you don't define the type here, it's just going to return a query interface instead of your typed query interface. And once again, that's just for type safety. All right, then getting to setting it up. So after you've got your query or type query interface back, you can then go and set stuff like parameters and hints and those types of things. So there's two different types of parameters you can set. It's either named parameter or a numbered or an ordered parameter. So with a named parameter, you actually, in your where clause, just go and say colon and the name of the parameter. So you can call it whatever you want to call it. Or if it's a numbered parameter, which is, I think if you used JDBC before, you'll see there's a lot. You've got your little question mark, but you actually have a question mark with a number after. So 1, 2, 3. Because normal JDBC, you just have the question mark, and you have to kind of remember which number is where. And you can mess that up royally. The only thing is when we get to native SQL only supports the numbered one, although this is kind of provider specific. It has to support it, doesn't have to support the named one, but I know Hibernate does support a named query in your native SQL queries for a parameter. Then when setting these parameters, the field you are setting it against, you need to look at your casting. So if you've got a string value there, a field that's a string, you can't go and put a integer as the value. It's not going to do that casting for you automatically. So looking at your boxing and unboxing type stuff on that, so just be aware of that. Then the other thing you can also do is you can set query hints, and they sort of call these sort of JPA extension points, and these sort of add extra features to the JPA without actually having to change the actual API of it. So there's one or two things that's in the spec itself. I think one of them is the timeout, but otherwise there's a lot of provider-specific hints that you can add. So of course, if you're going to use provider-specific hints, then you're not going to be able to port this to another database or another provider easily. You just use the set hint to do that. Then executing these queries. So depending whether you've got a query or a type query, you're of course going to have to do some sort of casting there. But you either call the get single result if you know you're only going to get a scalar value or one specific thing back, or the get result list. So if you're going to get more than one back, 0 or more. So once again, this one is almost like the find and get reference. If you use a get single result and there is no result coming back, it's actually going to throw no result exception. So that's something to look out for. The get result list will just return an empty collection. So nothing to worry about. So I said, looking at that, we'll do, like I said, we create our query there. Set in our JPQL. Here we're using a numbered exception. I think one thing I forgot to say is when we set the parameters, so if you're using a name, you actually just specify the name there. So we've specified the parameter name as :name. So when we set it, we're going to say name is equal to same, it should be Sam. And if you're using the numbered one, like the question mark 1, we're just going to say the number 1 or 2 or 3, whatever the number is, and the value we want to put in there. And that's it. So one thing that I found with the JPQL and especially the criteria API is just playing around with it and seeing how it works. Reading it and seeing it on the slides isn't really going to give you insight into it. It's still going to be sort of up in the air. You have to actually play around with this and try it out. So let's look at some of these queries. So I've sort of started showing you some of these. So doing a normal create query. You said from entity manager to create query. Specify our entities we're going to select from. So here we're not going to specify the table names. So just to show you, so for this specific demo, I've set up the table names and I've called the department DEP and the employees EMP, just to sort of show that there is a difference. So if I was doing normal SQL, I would have said select splat from DEP, but because department is the name of our entity, to define it here, we actually have to say department, and that's uppercase. So if we're going to put it as lowercase, it's going to tell you, I don't know about department with lowercase. We're doing a join on employees, and we're doing that through our department. So d.employees, which is the attribute name there. So if we go to department, we can see here's our employees attribute. Once again, it's lowercase, so that's lowercase is what we have to use in our JPQL query. And we're going to define a parameter here, where the name of the department is equal to the name we pass in. So we get our query, which is our type query interface. We're going to set our parameter. Because we're using a name parameter, we're going to say name. And the value we're looking for is Java. And then to execute this, we're going to say get result list. So if there aren't any employees that work for the Java department, it'll just return an empty list. If we only wanted one specific employee, one specific department, and we use the get single result, and there wasn't a department, it'll throw the no result exception. So it's going to do that. If we're looking at our name query, once again using entity manager, keep it the name. So name we defined on our name query here, and our query type. Select all of those. And so this works sort of the same. We get our interface back, and on our interface, if there was a parameter, we could have set that as well, and we just call results. So these two queries just print out the list of employees. So the one is all the employees, and the one is the employees that work for the Java department. I just go and run this, see it working. So you can see the first one just prints out our employees that work for the Java department. And our second one prints out all employees. So there's 6 of them. Prints it out. So cool beans. So it's quite straightforward and easy. I think the only place time this sort of becomes a bit hairy is if you're doing funny joins or including aggregate functions and so on, because then it kind of looks different because it's not like your normal SQL statements. So looking at our native SQL query, so this is your normal straightforward SQL that you write in SQL Server or DB2 or Oracle. And the 2 main differences here is that instead of doing create query, you're going to do create native query from Entity Manager. And with the create native query, even though you can specify the type that's going to be returned like query, it always returns the query interface. So create native query doesn't return a typed query interface. So that's the only thing that's kind of weird there. However, you can do your name query as well, and here it's just named native query instead of named query. And for this one, you do specify a type, and because you specify a type, you'll get a typed query back. One thing is, if you are going to use this, you have to set the result class when using it. So is looking at a department where I set a native query. If I've got a native query here, I have to set the result class on there. If you don't, Hibernate doesn't like it. And I said sort of because this is a native SQL query, you can see that straightforward SQL select star from dep, which is the name of the department table. So here we're not using entities. One thing with JPA2 is whichever type you return, it has to be an entity. So you can't return non-entity types. 2.1, you can return non-entity types. But for 2 and what we're writing exam about, you can't return non-entity types. So executing it, like I said, once we do our create native query or create named query, we're going to get a query or a type query interface back. You can then go and set your parameters. Only thing is it's only the numbered ones, so you can't use named. Although some providers do allow you to use the named one, but according to the spec, it should only be the numbered ones. And the other thing as well is that you need to be aware of is that whenever we're going to return, because you have to return a specific entity type, you can't return non-entities. One of the ways to specify, so if you've got a table, and instead of creating another entity where you're going to overwrite the aliases for those fields, so let's say I've got here, we're going to return a department, but it's in the other department, it's maybe a stored proc that's returning it or something else, and instead of returning the ID and the name fields, like we've got normal for a department entity, it's going to return an identifier and another department name. So to do that type of mapping, you do a SQL result set mapping. So for this, we're going to give it a name. We're going to tell it, say, what type of entity it's supposed to return. So this is actually going to return a department for us, although the names aren't the same. And then we're going to do the mapping for the names and the field result there. So it's just giving us a way of telling the provider listening, although this thing is returning fields which don't match up with this specific entity, it is this entity and these fields map in this specific way. So this is something to be aware of. There's a few fancy footstepping you can do around this. Chapter 10 of the book has a whole section on it. But I think for the exams, you just kind of need to be aware of it. I don't think there are any questions specific to this, but don't quote me on that. So looking at our demo and the native queries, let's go to our test here. Let's comment these two out. Comment these two, 3. So all right, so this is our normal native query that we're going to do. So instead of create query, we're going to do create native query. So that's the one difference. The other one is here we're going to use normal straightforward SQL. So select from dep, which is our department table. We're going to do an inner join on employees. So this is the exact same query we did with the JPQL earlier on. So we're going to do an inner join on that. Do our normal inner join on that, where the name is equal to $1. Because this is a native query, we have to use the numbered parameters. And even though I'm specifying it's going to return an employee class there, because I'm using create native query, it can only return the query interface. So it's not really type safe. So although I can do the casting here, you can see it's not checked. So the IntelliDate tells me, hey, you might want to check this. But I say because the only difference is we're using create native query, but still we're getting our query interface back. So if we can set our parameters, we can set our hints, all that type of stuff, and then we actually just go and say get result list, and that's going to do exactly the same as our normal create query. So the only difference is just the way we actually got to our query interface. Otherwise, it's exactly the same as our JPQL queries. Then looking at the named one, so on our department, like I said, the same way. The only difference is sort of a named query, so we call a named native query. Straightforward SQL, and we have to specify a result class there. Works exactly the same. We get a type query here, we can execute it. The only other one I just wanted to show you is where we use our SQL result mapping. So here we're going to get all the departments. So the only difference is we're still going to do a create native query as before. We're going to select our fields there, And the only difference is instead of defining the actual class there, which would be something like department.class, we just give it the name of our SQL mapping, which is other department, and that's what you defined in here as the name for that. So if we go and run this, return all the employees that work for, I don't remember which department I said. So all the employees that work for the query department, there's one. Next query, which is our name query, which just returns all our departments, that's that. And then the other one is just the SQL mapping, the SQL result mapping, which returns all the departments. So easy, straightforward, nothing weird there. So for the native queries, the only thing is just knowing that the native query only returns the query interface, and that you always have to return an entity type. For JPA Spec 2, 2.1, you can return non-entity types. So last, what you're going to be looking at is criteria API. So this is a bit different if you haven't worked with it. So I don't know, it doesn't feel very natural the way you work with it. If I look at something like the .NET Link language and the way that works, it just feels a bit more natural. This kind of feels weird when you're using it. So what you're doing with the criteria API is we're actually building up that query. So previously with the JPQL, we actually just said select E from employee, and that's where we built it up. Or with native queries, we do select star from employee, from emp table or dev table or whatever. So what you're doing with criteria API is actually building that up, but using normal programming API. So the first thing we do, we're going to get our criteria builder. And that's what you're going to use to create our criteria. So it's almost like getting your entity manager. So you get your criteria builder, and then you're going to create your query. So this query object, this criteria query, is the same as our query or type query interface in a way. So that's where we're going to get that from. So you're going to say what type that's going to return, and then you go and set up a root, which is sort of your from, so where you're going to select from. So if we're saying select from employee or select from department like we did before, that's where you set that up. So c.from, which is our criteria query. We'll say from the class you're going to use that, and that's going to set up your root. So, and then we're going to set up our select statements and our where clauses. And so I'm actually going to demo this, or maybe explain it a bit better, because it is, like I said, I just find it weird the way it works. So let's go and look at that. Comment that one out, comment that. All right, let's close this down. Right, so I said first thing we're going to do is we're going to get our criteria builder, and we get that from our entity manager. We then go and set up our criteria query. So this criteria query is what we're actually going to use to create our query at the end. So we can see here where we do our create query, like we did for JPA query. We're actually going to pass this criteria query in there. We say this is what we create. So from here, it's going to work the same as the JPQL or the normal native queries. We're going to set it up. So this first bit here is we're actually going to set up this sort of SQL we've set up there with a normal SQL, or this JPQL query we've set up here. So we're doing the same thing. That's what you're pretty much doing with that criteria query, setting up that, I was going to say string in a way. And we're going to say what type it's going to return. So like with our queries here, we're actually saying that the return type is employee class. And with our JPL query here, we're saying return type is employee class. That's what we're saying our criteria query is going to return. It's going to return employees. Do we need to set up our root? So this is where are we selecting from? So we're selecting from department in the other ones. So you can see we're setting up root here, which is of type department. And we're using a criteria query .from, and we're going to say we're going to select from class. So this has got nothing to do with the return type. This is all to do with where the type we're selecting from. So you set it up as your root, and then you can do a join. So you can set up a join here. The first one is our sort of left hand or root entity, and then our second one is the one we're joining to. So we're going to say we're going to call it employee join or whatever. And from our root, we're going to say we want to join our employees on there. And the field we're saying there is the attribute. So same as a JPQL query, we use the attribute. So this isn't the actual entity. It's from department, it's our relationship we want to join on. And the attribute is called employees there. So it's pretty much the same as we did here with our JPQL. We want to select on department, so department is our root. We're going to do a join on the employees, which is the employees attribute on our department entity. So that's the same thing we're doing. We're saying we're going to join on that. And then to set up a parameter, so for that we set up a parameter expression. Using our criteria builder, we set up a parameter, so it's a name parameter, so we say the type that's going to be filled in there is a string, and its name is name. So then doing our select, we want to say we can select the employee join, so the same as we did select E. From there, we can do it there, or on the select you can say I want to select the name of the employee, I want to select the department, whatever you want to do there, and then we set up our where clause. So using our criteria builder again. So your criteria builder is sort of what you use to build your parameters, and what they call paths. So we're going to be doing this in 2 weeks' time. We're actually going to have a whole session about criteria API. So what we're setting up here is we're building paths. So we're going to say we want to equal it, and we want to look where the department's name. So to refer to the department entity, we use department root. For it to refer to employee, we say employee join. So when you get that name, you want to say where it's equal to department name, which is this query of this parameter we've set up here. So you can see it's quite a lot that we need to do just to set up a normal simple select with a join and a where clause in there. And I also say it doesn't feel very natural to me the way it's done. And all we do then is we take this criteria query, we pass it in as the parameter for create query on this manager, and then from there we execute it like normal. We go and set our parameter that we've set up there. We call our get result list. This is a type query, so I don't really need to cast it here. You can take that out. And then we get our number of employees. So I say so it's a lot you need to do to set it up that way. And this might be a bit more natural if you want to do dynamic type queries. This might be a bit easier or more natural for you, but like I say, sort of it's kind of really weird for me. If you compare this to something like .NET's Link, it just works. .NET's Link queries work the same way. You've also sort of got an API, but that sort of looks more like normal SQL instead of looking like craziness that's happening here. I can probably just execute this query. This will return all employees that work for the Scala department. So you can see there's 3 of them. So that's the introduction to queries. So you need to be aware of the criteria API, but I say we're going to be doing that in 2 weeks' time in detail. The native queries, there is no specific topic about it, and it doesn't look like there's a lot of questions around the native queries. Just be aware of the little caveats around the named query, the native queries instead of create query, and that it returns a query interface instead of a type query interface. And just know that it needs to return an entity type, and you use your SQL result set mapping if the fields are a bit different from the actual names on your entity. And then next week we're going to look at JPQL queries again. There will probably be a bit more of repetition from this, but for the introduction you kind of needed to know all of this. So we'll go into a bit more detail next week around that. So let's see if there are any. Seem like there's any questions. All right, so quiz once again this weekend, 10 questions. And then for next week, chapter 8 of the book, that's all about the JPQL queries. You can maybe even read it this week already. I say sort of the chapter we did this week was 7. It already has quite a bit about the querying in there, where chapter 8 just goes into the JPQL specific stuff. So you can sort of read the two together, or section 4 of the specification. And that's it. So the attendance keyword is query this week. So if there aren't any questions, then that's it. I'll see you guys next week. So I think next week will probably not be as long, because it's going to be a lot of repetition from this week. Also, anybody that missed Monday night's Josie Jug, was a good session. It was actually quite cool. Really enjoyed the guy. Quite a few nice little war stories about performance, vegetarian stuff to look out for. And then also, Rory just reminded me now, is on November 30th is the last Josie Jug for the year. It's going to be at Standard Bank in Rosebank, so it's going to be quite cool. It's going to be the mobile guys, I think, are doing a thing on the Elk Stack and all that. We're going to do a bit of that. So if you want to get into the whole Elk Stack and with things, Splunk and all that type of stuff, and Kibana and I don't know what all that is called, that'll be quite cool. So going to check that out. And then we're also looking for the Josie Jug. The people who've gone to the developer user group before or haven't, their last one for the year is quite a cool one. It's sort of, they do a Geek of the Year type event, so it's a quite fun little pub quiz type format. So it's at Microsoft. I think it'll be like the first Tuesday in December. So it's quite fun. There's a lot of prizes they give away. It's a lot of fun. So we're looking at combining the Josie Jug, people going there for that as well. So that'll be quite cool. So if you can make that, pencil it into your diary. I think it's the first Tuesday in December. And then also the 30th of November at Standard Bank. Going to look out for that. And for the people who want to find a reason to go to this, like I say it's something different. You kind of meet up with other people, your peers in the group. It sort of gives you a different perspective on how people do things. It's almost the same thing as like doing peer programming and seeing how somebody else does something. Going to these events, you can see how other people think. You can talk to people about. There's a lot of questions that get asked that you might know about. Might be technologies that you haven't seen before, which they show and showcase and so on. So that's quite cool. And also always, so we're saying there's also most of the people sort of go out and have some nice food. We've really progressed. Last year there was a lot of pizza. This year we've upgraded to sushi everywhere and burgers and chips and delicious little finger snacks. Standard Bank is doing like 200 Rand per head. So it's almost like a plated wedding type menu maybe. I don't know. Might even be a DJ afterwards. The chicken song. So anyway, everybody, see you next week. Cheers.